on prepositions using truth tables. Good. So the question is, what then is a preposition? What is a preposition? Just a minute. A preposition is a statement which can be true or false, but it cannot be both at the same time. Okay, so for example, if I ask you if it's Messi, or when I make the statement, Messi is a footballer. Okay, Messi is a footballer can be true or false. Okay, another statement will be the earth is round. Okay, the earth is round could also be what, true or false. Okay, Accra is the capital of Ghana. It can be true or false. Okay, but there are certain statements which are not prepositions. Statements like questions. Do you speak English? Okay, so if somebody asks you, do you speak English? You cannot say that it is true or false. Okay, the same way, if somebody gives a statement, a command, come here. Okay, so if I say that come here, you cannot say it's true or false. Come here is a command. Questions are also not prepositions. Okay, so you take note of that. Yeah, now let's take some other examples. So we're saying that in prepositional logic, a preposition is represented using a lower case letter, such as P, Q, R, S. Okay. If we have just one statement, we'll use the first letter, which is P. If there are two statements, we use P and Q. If there are three, we have P, Q, R, 4, P, Q, R, S. Okay. But what we should take note of are the letters capital T and capital F. Okay. Capital T and capital F in prepositional logic, okay, are not statements. Okay, they are not statements. We'll come to that in the next slide. I'll explain better on that. Okay, so we have an example here. We say, for example, we can use the notation P is the earth is round. Okay, so P, then you see you have the column representing it's a statement. Okay, so the statement P is the earth is round. Okay, to define P as a preposition, the earth is round. Okay, let's continue. Now, one or more statements can be put together, okay, to form compound statements. And to do that, there are a number of rules which are used, okay, which are used to combine statements. So, for example, if I have the statement Messi is a footballer as the statement P, and Q is footballers score over 20 goals, okay, then I can combine the two statements with a conjunction like and say that Messi is a footballer and scores more than 20 goals. Okay. Once I do that, I've formed a compound what? Statement. Okay. So there are a number of principles that are used in combining statement. But before we proceed, let's take a little exercise. And in prepositional logic, we have what we call as truth tables. Okay, truth tables are tables that presents the possible truth values, okay, of any given statement. So for example, if I have the statement P, if I have a statement P, okay, P could have the values true or false. It can be true or it can be what? False. So in the creation of a truth table, you construct a table like that. Then you have the statement P with the possible values what? True and what? And false. Okay. Now, if we have two statements, okay, if there are two statements, that is P and Q, okay, then you realize that because P itself has the statement true and false, and Q also has the statement true and false, okay, then the possible, okay, values on the truth table for the two statements, okay, are going to be the combination of these truth outcomes, okay? What I mean by the combination is because we have the first event and then the second event based on the multiplication rule. If the first event has true and false, okay, then the second event, given that the first is true, the second could also be true or false, okay? And given that the first statement was false, the second could also be true or what? False. So which means that at the end of the day, we'll have the truth table for two statements looking like this, P, Q, okay? And because we have two statements here, we'll write two T's. So truth, truth, okay? Then for the first one is true, okay? Where T, truth and truth, and then truth and false. So truth, 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 false. Okay, then we come here also. That would be false. Okay, false, true. Okay, and then false, false, false. Very well. So this is for two statements. Okay, this is for two statements. Now, the general principle guiding the number of combination, okay, of given statement is the formula 2 raised to the power n, where n is the number of statements, okay? So if we have three statements, say P, Q, and R, then your n is 3. So it means the number of combination we expect to be 2 raised to the power what? 3, which will be equal to what? 8, okay? So if it's equal to 8, okay, then what we do is we construct the table. Of course, we could have used the tree diagram, but that would be lengthy, okay? Now, I'll show you a shortcut very soon, okay? So, okay, let's do this. Before we construct for 2 raised to the power 3, let's look at this. In the case of two statements, we had 2 raised to the power 2, okay, which was what? 4, okay? So because we're going to have 4 combinations, what you first do is you divide this 4 into 2, okay, and you will get 2. So you write 2 truths, 2 false, okay? Then you divide the 2 into 2, you get 1. So you write 1 truth, 1 false, 1 truth, 1 false. The same way as a shortcut, we'll divide this into 2. Okay, it means we are going to get 4, right? So we'll write 4 truths and then 4 false. So let's do that. We have true, 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 true. Okay, that's for the 4 true. Then we have false, 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 and finally we have false. Okay, good. Yeah, but let's not forget the headers. That's P, Q, and what? And R. Okay, so we are dealing with 3 statements. So P, Q, and R. Okay, then we divide again by 2, like I showed you from there. That will give us 2. So we're going to write 2 truths for the Q. 2 truths, 2 false, 2 truths, and then 2 false. Okay. Then once you divide by 2 again, this is 2, right? So once you divide by 2, we are going to have 1. Okay. So then you write true, false, true, okay, true, false. Then we have, so it follows like that, true, false. So here you have just 1, 1, okay. So false here. Then we have true, and then we have what? And then we have false, okay. So this gives us the combination for 3 statements. I hope the development of the truth tables are clear enough. Very well. Okay. So if there are any questions, you can ask before we move on. But if not, then I'm moving on to the next slide. Okay. So let's continue then. Yeah. So like I said earlier, we could combine we can combine 2 or more statements using logical operators. Okay, and then 2 of such logical operators are the conjunction and disjunction. Okay, conjunction and disjunction. Good. Now, what do we mean by conjunction? Conjunction is and. Okay, the conjunction of 2 statements P and Q is and. Okay, and it's written like that. It's like the carrot. Okay, good. Now, when we talk about and implies that both statements have to be true for the resulting combined statement to also be what? True. If one statement is false, then the conjunction of the 2 statements will be false. Okay, so the truth table for conjunction is given in this table, which I want you to take note of. So take note of this table. If possible, put it down because we'll use it for analysis subsequently. Okay. So having taken note of the table, you realize that the only scenario where we'll get a truth value is where we have truth and truth. Okay. So truth and truth will result in what? Truth, right? Otherwise, we have what? False. Okay, truth and truth will result in true. Otherwise, we have a false value. Very well. Then we also have the disjunction. The disjunction, also known as or. Okay, is that is P or Q. Okay, P or Q. P or Q. So that is a disjunction. And disjunction means that one has to be true for the whole statement to be true. At least one has to be true. So if we say that Messi is a footballer, or Messi scores goals or scores 20 goals. Okay, once Messi is a footballer, it's enough. Even if he doesn't score 20 goals, because we are using the word or, and Messi is a footballer indeed, then the statement, the compound statement remains what? True. Okay, the compound statement will remain true. And for the sake of the size, the bundle one, the bundle width, and the size of our recording, we always recommend that our videos will be put off. Okay, that is why I don't have my video on. Because some people will struggle coming in once we have videos on. And our recording tool will be too huge at the end of the day for me to send. So I'll recommend those of you who have your videos off to put it off. Those who have it on should put it off. Okay, let's continue. So Debbie, can you hear me? Debbie, can you hear me? Okay, let's continue. Okay. Yeah, let's continue. So for all, like you can see from the table here, okay, the only instance where we get a false for the resulting compound statement is when both statements are false. Okay, and I'm sure you've taken notes of the table as well, because we'll be using it for analysis later. Okay, let's proceed. Now, we have statements here which we want to conjunct and disjunct. We have the first statement, P, which is the earth is round. And then the statement Q, a decade is 100 years. Okay, clearly we know that P some way, somehow is true. We can say, for now, we can say the earth is round, okay? And then a decade is 100 years. We know that statement is what? Is false, right? Decade is not 100 years, but earth is round. At least we can consider that for the purposes of this class, okay? Now, then the conjunction of P and Q, the statement P and Q, which is the earth is round, and this is the conjunction, okay? This is a conjunction. So the earth is round and a decade is 100 years. will be what? Will be false. Okay, will result in a false statement. Why? Because we said once you have truth, okay, and a false, okay, it will result in what? In false. Okay, so a truth and a false will result in a false. The only condition under which conjunction will result in truth is when both statements are true. Okay. On the other hand, P or Q, that's a disjunction of P or Q, will be written as the earth is round or a decade is 100 years. We know this is false, but the very fact that this statement is true, okay, makes it true or false, which is what? Which is what? True, okay? So the truth disjunction false will give us what? Truth, okay? Good. And on that note, you would notice that in prepositional logic, like I said earlier, the values T, capital T, and F, capital F, are reserved for what? Are letters reserved for the truth value. So it's either true or false. So assuming I write a statement like P or true, okay, P or true, okay, when I write a statement like P or true, this is not a statement. There is only one statement here, okay? So in the construction of the truth table, it will look like this. You have your P is a statement, so it has two possible values, which is true or false. But the value T is a value. So it means you just repeat the same value in the table, okay, for onward analysis. It's not a statement you have two possible values. It's a value, so truth is truth. If it is false, it's also false. Okay, it does not change. So take note of that. Very well. If there are any questions, you can raise your hand. If not, I'm continuing with the presentation. But you can let me know if you have questions along the line. Good. Now, another statement we need to take note is the negation of a statement. Negation is just, okay, it's usually written as P bar like this, okay? So we write, there are actually three ways of representing it. So we have P bar like this, okay? Which we usually refer to as complement. When we went to set, you saw this over there, okay? Prepositional logic, we have it this way, or we can have it this way, okay? Or we can have the negation of P this way, okay? So either way, we are still saying the same thing, which is the negation of the statement P, okay? And it simply means not P, okay? So not P, if P is true, then not P will be false. And if P is false, not P will be true. So if P is the earth is round, then the negation will be what? The earth is not round, okay? Which will be a false statement, given that P is also true. Yeah. So I have a little combination here. This is a loop, okay, where you have the representation is a circuit, a digital circuit, where you have this, okay, logical propositions represented, okay, using gates. So this is the conjunction, or what we call as the AND gates. The conjunction we'll be looking at, okay, is called an AND gate. An AND gate, okay, an AND gate in computer architecture or digital electronics, okay, where we have the OR gates, which is the disjunction. This is an OR gate, okay. So basically, let's do some little fun. I think something little. Let's go out of mathematics class a bit and come back. Okay, so let's see what this basic circuit does for us. Let me clear the screen. So looking at this basic circuit, if I decide to on, okay, I have my AND. You see, look at it carefully. Let's begin with the OR gates. For the OR gate, we said if one is true, that is, here we are talking about on and off. So if one statement is on, then you can see that 3 bits, okay, have been enabled in the output, okay, 3 bits, because this is not a properly designed circuit. I've just connected 3 lines, okay, of the digital LED screen, okay, to this OR gates. So we have all the 3 bits, 1, 2, 3, displayed because we have 1, okay. So we have a true or a false statement coming out. If you have a true or true, it will remain the same. But if you have false, false, it will go off, okay? Good. Now, on the other hand, let's look at what happens to an AND gate, like we said. If one is true and the other is false, nothing will happen, okay? Until you have both to be what? Both to be true. So once everything is true, then the bit is turned on, okay? And then we have just one signal cable into the LED display. That's why you have 1 bit on. Class, I hope you can see what I'm doing. Hello?
Yes, I can see what you're doing.
Okay, you can see the Logisim, the program I'm displaying.
Yes, I can see it.
Okay.
The digital circuit.
Yeah.
Yes.
Not on the PPT. Let me just check. Let me be sure from this end. No, you were not seeing it. This is what I'm displaying. You were not seeing this, right?
Okay, we didn't see this.
Yes. So let me touch on it again. So this is an OR gate.
Okay.
OR gate. Okay. This is called an OR gate. This is the AND gate. Okay. This is the A and D. That's the AND gate. Okay. And per the description, what we just demonstrated, okay, we said that for an OR gate, you only needed 1 circuit to be on or to be true. Once the disjunction is true, okay, you will find out that 3 bits have been displayed on the LED screen. Okay, 1, 2, 3. I connected all 3 to the same line. Okay, it's not properly designed for this thing, just for demonstration. So if you have both being true and true, it remains true. But if both are false, then it will go off. Okay, whereas when you come to AND gate or the conjunction, if one statement is what? If one statement is true and the other is false, it means off.
Well,
But
let's
if
see.
both are true, then the bit output, okay, is on. So the bit is displayed on the LED screen, like you can see. The same way when you come to the other end gate, you put one on, nothing will display until you have both on. Okay, and then once we put on this, we can see that our statement has generated what? The digital letter 8, okay, for us. That is how our computers display, our phones and computers, calculators and all that display our figures for us. So this whole concept we are learning is very relevant to us as scientists, like we said from the beginning. Now let's go back to class, to mathematics class. That was a bit of digital electronics. For those of you who have taken the course already, I'm sure you get a better picture. Okay, now we are told to write the truth value of each of the prepositions below, where we've been told that P, the statement P is true, the statement Q is, sorry, P is false, Q is true, and then R is true, okay? It's written here. And we've been told that A is P or Q. What will be the result for P or Q? Will it be true or false?
It will be true.
Yes, because we are dealing with disjunction, okay? And once one is true, that is Q is true, the resulting statement will be true. Okay, then when we come here, not P